Hello, I'm Mrs. J, and today we're going to talk about antiderivatives. If f prime equals f of x, then f of x is an antiderivative. So we're just working backwards. It's also called the indefinite integral when we're not plugging values in. So that the integral, when you take the integral, you want to make sure that you add a constant, because if you remember when we took the derivative, the constant dropped out, so we need to put it back. First rule is the power rule, and this rule is when n does not equal -1. Remember when we took the derivative, we multiplied and then subtracted 1? Now we're going to add 1 and divide. So you add 1 to the exponent and then you divide by that value. And then plus your constant. If you have a constant, it's the x comes back, because if you remember, x is the 0, and plus a constant. When n does equal a -1, that's a special case. It's a natural log. So if you had k over x, or bringing the x up, kx to the -1, it becomes the natural log. Let's try some. So if we have the integral of 6, that's the constant, it becomes 6x plus c. Let's look at 3x squared plus 6x minus 9. If we took the derivative of this, 2 times 3 is 6x to the first plus 6, and the 9 goes to 0. So what we're doing now is going backwards. If we take the integral of 6x plus 6, this one you add 1 and divide. So we have our 6x, 1 plus 1 is 2 over 2, plus a constant becomes 6x plus c. If we reduce this, 3x squared plus 6x plus c. Notice? The only thing is we need more information to find out what this value was, and that's why we put the constant. Let's try some more. And this just lets you know what you're taking the integral with respect to. So we're adding 1. 5x cubed over 3 minus 6x, we're adding 1, so it becomes x squared over 2 plus 3x plus c. And this one can reduce. Same thing, add 1. So 16y to the 4th over 4 plus 9y cubed over 3 minus 6y squared over 2 plus 3y plus a constant. And then these will all reduce. Yeah, 3y. And this becomes another 3 cubed squared So if we have this one, we're going to go 56t, adding 1 is 7/2 over 7/2 plus 18t, adding 1, 9/2 over 9/2 plus c. Now you can flip this and multiply. So 18 divided by 9 is 2 times 2 is 4. This would be 16. And there you go. There is no quotient or product rule. It's substitution. So we would bring this up. Now when we do this one, again, it's not -1, so you can do add 1 and divide. When we add 1, we get a -2 divided by -2 plus c. We get -2 x to the -2 plus c. Okay, this one, we have to bring these up, and this is just e to the first power, so this is just a number. When I move this up, I'm also going to change the exponent to a 1/2, so this would be x to the -1/2. Adding 1, then we have a negative x to the -5 over a -5 plus e. Adding 1, we get x to the 1/2 divided by a 1/2. Negative is a positive. X to the -5 over 5, or you could bring that down, plus 1/2 flipped is 2e x to the 1/2. Yeah. This one's a natural log because it's x to the first in the denominator. So it would be 9 natural log of x minus 3, minus 3, oh, I hadn't shown you the exponential rule yet. Okay. For the exponential rule, the function stays the same, and then you divide by the derivative of the exponent. So we just divide by the derivative of the exponent. So this would be e to the -0.4x over -0.4x. So you take the function as it is, but then divide by the derivative. Remember before we multiplied by it, now you have to divide by it. Let's try another e. Okay. Exponential stays the same, and then divide by the derivative of the exponent, which is just 2, minus 4u adding 1 squared over 2 plus c. I think I forgot my c on this one. Be careful. Try one more. V squared minus e to the 3v dv. So when we take the integral, we add 1 to the exponent and get v cubed over 3 minus, this one just stays the same, and divide by the derivative of the exponent plus c. And that's all for the rules.